Have you ever started typing a text message and your smartphone immediately suggested the exact word you wanted to use next? Your phone doesn't know who you are texting, and it doesn't understand the concepts you are discussing. It has simply learned a statistical pattern. If you type the word happy, there is a very high probability the next word should be birthday. Now imagine taking that tiny, everyday predictive feature and scaling it up. Imagine an autocomplete system that has read millions of books, articles, and websites until it can predict not just a word, but entire pages of text. Recognizing this simple pattern of predicting the next word is the foundation for understanding how even the most complex AI actually works. This brings us to the large language model, or LLM. It is the underlying technology powering popular tools like ChatGPT and Gemini. When you ask one of these systems a question, it does not go into a hidden library to retrieve a pre-written answer. Instead, the model generates its response dynamically. It predicts just one word at a time, locking in the highest probability based on its training. Instantly, it repeats this prediction cycle, building a sequence word by word until it forms a complete thought. Beneath the surface, these models are sophisticated prediction engines, not thinking machines. To make a word-guessing game perform this well, you need massive technological infrastructure. The large in large language model refers to its sheer scale, training on billions or even trillions of words collected from the internet, books, and research papers. As the model learns, it builds billions of internal connections between words and ideas. We call these parameters. Think of them as a massive map helping the model navigate relationships. A model with more parameters can recognize much more complex, nuanced, and diverse patterns, which is why it can answer questions and write in many different styles. The AI doesn't store the documents it read. It stores these learned statistical patterns. Today, there are several major LLM families available to the public, including OpenAI's GPT, Anthropic's Claude, Google's Gemini, and Meta's Llama. Even though they are built on the same basic idea of predicting words, these models are distinct from one another. Different companies use different training data and focus on different goals. One model might optimize for coding, another trains to be more creative or follow stricter safety rules. Because of these unique recipes, if you ask different AI assistants the exact same question, they will naturally generate entirely different answers. When an AI writes a moving poem or gives helpful advice, it feels like there is a person on the other side of the screen. This often leads to the belief that the model is actually thinking, or that it has its own feelings and consciousness. In reality, they are simply very good at mimicking how humans use language. They don't have beliefs or emotions. They have probability. There is also a very common assumption that every AI assistant inherently searches the live internet to formulate its answers. Most LLMs rely purely on what they learned during initial training. If an AI can search the web for live info, it's because an external tool was added to the application, not because the language model does it alone. Understanding these limitations is just as important as knowing what the technology can do. When you type a prompt into an AI, you are setting off a massive chain reaction of statistical predictions, not talking to a digital brain. Because the model is just predicting what sounds right, it can easily create a sentence that sounds very plausible, but is factually false. This is why you must always verify important information. But once you know how these DESs work, you can write clearer, more specific prompts to help guide those statistical predictions toward the exact result you need. By understanding how these models use statistics to predict language, you are no longer just a passive observer. You have the insight needed to use AI responsibly and confidently in your everyday life.